Okay, let's starting with this problem. Okay, so I got to erase the screen. Okay, we starting with this. When we solve the type of this problem, first thing that we have to do, we have to set up the datum or the reference line. Okay, the reference it should be some point on some axis that has no motion. For this case, the red line should be set up as the reference. Okay, so according to this, we measure the distance from the reference to any point that has the motion. So we have three particle, right? We have three blocks. That is block A, block B, and block C. So we can, from reference, we can represent for SA, that is measure from reference line to block A. And SB is measure from reference line to point B. Actually, you can measure to block B also, but it's maybe more convenient because the block B and the pulling of block B, it should be because it's connect together. So then it is the same velocity. So then we will just measure it just only at the pulley only, okay, to the pulley B. That it should be enough. Because we would like to construct the constraint equation that is depend on the length of the root of the Polar system like this. And for SC also. Actually, if we consider the root in the Polar system, we have this, right? Okay. So we can construct the constraint equation for these cases. The constraint equation from these cases, you will see that if we consider the line, this line, okay, this line, and this line. Okay, actually it is the same root. Okay, so it's equal to SA. Actually, if we draw the picture, it's maybe draw just only this, that it should be all right. Okay. Okay, so we can write the constraint equation that is composed of this line, that is SA, right? Plus 2SB and also SC. Okay, and it's become the constant length of L. And after that, we take a first derivative to this equation, and we have to set up the positive sign convention according to the reference. Reference is here, so then the positive direction should be downward, is positive one, because we measure from reference to the point that we would like to consider. So according to this, we can take the first derivative to this equation, and we can obtain the relationship. When we take the first derivative to S, we obtain V. Okay, and we have this relationship. And from the problem, it's already give us that VA is go downward, VC is go downward, but it's different velocity. VA, the problem give us that is equal to 4 meter per second, and VC equal to 12 meter per second. We substitute into this equation, we can solve for VB. Okay, and after we solve for VB, we found that VB is negative value. It is minus 8 meter per second. Okay, it's minus 8 meter per second. What does it mean? Minus the negative sign is mean that it's moved in opposite of in opposite to the positive sign convention that we set up. We set up is to downward, it's a positive direction. So the negative is mean that the block B should be moving up. It should be moving up with speed of 8 meter per second. So it makes sense because when A is moving down, C is moving down, B should be moving up. Okay. Okay, this is match to our engineering sentence. Okay. So this type problem is, if you understand, you starting with set up the reference and then just set up the constraint equation and take derivative. It's very easy for this type of problem. Okay, so then we're moving to next problem. Okay, next problem is maybe more complicated because it's we have the two root. For this case, we have this one to form the constraint equation. We have this one, this length. And also we have another one that is maybe the green one. Okay, to form two length because it's different rope. Okay, it's different cable. This is the first cable, the red one. Sorry. We have to form the length for the red cable and for the green cable to set up the constraint equation. And then at first we set up the datum or the reference. And from this, we reference is measure to the point that we would like to consider the motion. It should be go down as the positive one. Okay, according to this, I use this example from the text of Hebrew. Okay, you can see the detail from the textbook. Okay, and you see that we can from the reference that we set up. First one, this is the first length. Okay, for the first one, you see that is equal to SA rate plus 2SC. This is 2SC. Is equal to L1. And for the green cable is equal to this one is SB. Okay, and this one is equal to SB minus SC, right? Okay, so then the constraint equation is become here and it is equal to L2 and L2 is constant. So then after we take the first derivative, we have two relationship. Okay, that we have the same value. For this case, we can solve by using these two equations. We can eliminate VC. This is the mathematics. Okay, you can do it by yourself. Actually, you multiply this equation by 2 and then eliminate something. You obtain this equation, right? After you got this equation, you know velocity B. VB is 6 foot per second. Foot per second, but the problem gives us that it's go up. So then when we substitute into the equation, we have to substitute it in negative. Okay? Okay? Because the positive sign convention should be downward because the datum is here and we measure down to the point. Okay, so downward is positive. Be careful. Okay, in dynamic, reference frame and positive sign convention is very important. So after we got that, we can determine for VA and VA is equal to 24. Positive one. Positive one is mean that it's go down. VA is going down. Okay, it makes sense, right? When B goes up, A should be going down. Okay, because it's depend on each other. So that's complete for this problem.